Okay, so welcome to this little video which will help you with the process of completing the square. Let's do a really simple one to start off with. If we were trying to solve an equation like x squared minus 10x minus 3 equals 0. Now this equation doesn't factorize. You can try if you like, but I promise you it doesn't. All right. What I want to do is, remember the end game is to get x equals. Okay, so a fairly obvious thing to do would be to add 3 to both sides because there's definitely no x in that 3. Right, x squared minus 10x equals 3. Now, the problem I've got at the moment is that the x is in two different places. If I could somehow write this as something like this, then I go from x being in two places to x being in one place, which is quite significant in terms of isolating x. Right, now, as we know, when we square a binomial, what happens is that whatever I put here multiplies with x and then doubles. So in order to get minus 10x, I actually need to put minus 5 in here. Just check that for yourself. When you square this out, you get x squared minus 10x. You also get 25. Now remember the metaphor of a scale. This thing was balanced initially. It's no longer balanced because we've added 25 to the left-hand side by writing it in this form. In order to address that, I need to add 25 to the right-hand side. That 25 is the negative 5 squared. Okay, now what the real magic that's happened is that on this line here, I only have x in one place, whereas here I had x in two places. Okay, so now what I'm going to do is I'm going to square root both sides. Remember that when you take the square root of a number of both sides, you could have both the positive or the negative square root of 28. And then lastly, I'm going to add 5 to both sides. So I end up with 5 plus or minus the square root of 28. Notice that I've got two irrational roots and that they are occurring in what we call conjugate pairs. I'm going to do a slightly harder one, right? Because you probably think I picked like an easy one. So let's do something like 3x squared minus 7x minus 1 equals 0. Right, exactly the same idea. I'm going to add 1 across to both sides, like I did last time. Now, I've got a problem here because of this 3. So what I'm going to do is I'm going to divide every term through on both sides by 3. That will certainly preserve the balance. Okay, now what I'm going to do is I'm going to try and write it in this form. Okay, and remember what I need to do. I need to halve this number. Now, half of 7 over 3 is actually 7 over 6. Right? You halve a fraction by doubling its denominator. If I was to square out the left-hand side, I would get x squared minus 7 over 3x. I would also get 49 over 36, which I did not have on this side. So I'm going to add 49 over 36 to this side. The reason I've written that down first, I'm actually going to change these thirds into 36 as well, just kind of for efficiency. And as we know, 1/3 is the same as 12 36ths. So what I end up with now is 61 over 36. All right. And here I've got x minus 7 over 6, all squared equals that. Square root both sides. Now notice what happens here is that the denominator will square root nicely, right, to 6. The numerator in this case doesn't square root nicely, it's just plus or minus the square root of 61. And then lastly, I'm going to add my 7 over 6 across. And I get 7 plus or minus the square root of 61 over 6. And you'll see, if we were to kind of solve this equation on a Silver Surfer, let's just quickly see if I can find one, you'll see that we get exactly that answer in exactly that format. Okay, so let's kill that and let's go mode 5, option 3, 3 minus 7 minus 1, and one of my solutions is 7 plus root 61 over 6, and the other one is the conjugate, 7 minus root 61 over 6. Right, I hope this little video has been useful. If there are other topics about which you would like me to make a video, please don't hesitate to ask.